Okay, today I speak about Vpython for Visual Python. It's a 3D engine, you can say, written in Python. And the talk is in two parts. In the first part, I just explain what it is. And in the second part, I speak about my experience with using it for teaching and for other stuff. So it's more about how it works in the practice. Okay, thankfully, I don't have to sit now so and say that the laptop does not work, because Thomas will do this for me. I'm very thankful. So what it is, you make three-dimensional graphic with Python. Vpython has a very interesting history. For example, it was once called Visual Python. It has a horrible outdated Wikipedia page that is not up to date. So it's quite hard to find actual information about it if you don't search very precise for it. Can we, next slide, please. Vpython is the work mostly founded by Bruce Sherwood, a professor in America, and his students and his wife. And he's teaching, I hope I have this correctly, physics or mechanical engineering. And the idea was to use modern technology in their teaching classes. And one of these ideas was to use then three-dimensional web graphics and little dashboards to better explain to students calculus for engineering problems. He is also author, or now co-author, of Matter and Interactions, which is like a standard physics books and quite popular, what I understood. Next question, please. Bruce himself is still active in the Vpython forums. It's a Google group, and he personally answers emails there from students, and I really admire, because he answered my email, even if I asked 3 times the same thing, because I did not understand his answer. And he also really answers some super random stuff from some guy from, I don't know, India, asked how he can make a 3D game, and then he or one of his students say you should maybe read this and this book, and maybe don't use Python, or use this and this language. So really a very patient and nice guy. And one of his last blog postings is that he's now retiring with over 86 years, and he gives the mentorship of the Vpython project to one of his colleagues, this Professor Stephen Speaker. But what I've seen, so this year Bruce was still active in the forums and answering questions. Next, please. Yeah, Thomas will later show you how to go into Vpython. You just head over to vpython.org. This is the webpage, and it's very interesting because it requires a 3D graphic card who actually works with your browser, so that your browser can use OpenGL. When you open this website, you have this little test thingy to the right, and later Thomas will show it live, and then you can click on run, and then you see here this 3D this ball in this 3D cube bouncing around. If you don't see this, if you see just a black screen, it means your system in this current configuration is not able to use Vpython because some driver is not installed, or maybe because you don't have a 3D graphic cards. The interesting thing about Vpython is that it's now split into 2 projects. One is, I wrote here the GitHub addresses. One is a system that Thomas later will show. It's called GlowScript, and this is Python who runs inside the web browser, but that you can also program in nearly Python, also it's a Python with some restrictions, in the web browser, and it's primarily meant for students or for classroom situations. You are in some classroom, you want to make an introduction into Python or 3D graphics, and all what the students need is working internet and a Gmail address to log in, and then they can work in the browser, code in the browser, and see the result in the browser. So you have a zero install environment. This is very nice. And this is called GlowScript. And another thing which is here written with Vpython 7. This is the real project where you download Vpython as a Python library, and then it works together with your Python environment. That means you have the full Python ecosystem, like Pygame or some sound drivers, joystick drivers, and can combine it. So it's 2 different things. In this presentation, we will show both variants. Please. Okay, all what you see now, the next 4 slides I stole from Bruce himself. It's about the architecture, and As you see, it's quite complex, and in the end, Python tries to generate JavaScript, and this JavaScript tries to control the WebGL driver and produce a web page. Yeah? So when you run a Vpython script, it produces a little web server, and your browser goes to this web server. Can you just click over these things? Yeah, I stole them. You can read later. Also, interesting thing. Vpython also runs inside a Jupyter notebook, and then you code in a cell from Jupyter notebook, and the output should also be in a cell from Jupyter notebook, which is quite handy. I tried, but it was last year, to do the same thing with Merino notebooks because they're so new and cool, and but I only managed that in a Merino cell, the output goes in another browser window, but maybe this is also fixed now. I can certainly not say. Okay, let's go further. Yeah, and this is the web close script or web Vpython area. And when you go here, it is necessary that you sign in using a Gmail address. And you can, even if you don't, or your students don't have Gmail addresses, you can still explore the example programs. You can even see the code of the example programs in Python and also in JavaScript, but you cannot modify the code. This is the big disadvantage. So it's recommended that when you create a workshop for this in a classroom situation, to 1 week before, say the teacher, please make sure everyone has a Gmail address, and then it should work. Okay, can we please go to the next slide? This is now inside this web close script, web Vpython. You see the little pictograms of all the examples. There are, if you see them and play around with them, you instantly understand, yeah, this was a physics teacher who made them. And if you click down in one and say view, you can see here the code. You see here, this is Python code, and the only difference to a real Python program that we know is that in the first line is written web Vpython. But you see the code and the outputs runs in the same browser. He has even the little hyperlinks for running and modifying. The slightly annoying thing or the hard to adapt thing is if the student makes some error, like forget some colon or so in a for loop, then the error message is a JavaScript message box who blocks the program, and he must then go back and then quit this error message pop-up. So it's also the Python that you see here, how should I say, it's an approximation of Python, but it's not 100% Python. For example, the for loop has an else clause, what I know, that you can use, and this does not work here. So it's not 100% perfect, but for most things that you do in a classroom situation, it's poor enough. But it means, of course, you cannot import modules that you used from Python. So they have, you get shipped with some commands that you need, like random functions, but you cannot, for example, now say you import some library that manipulates Excel files or so. That will not work in this website. Okay. And this, I hope we will manage to show this live. This wool close script is very connected with this book from Matter and Interactions, and there's even one very good game inside it. It's called Electronic Field Hockey, where you have so little magnets and you must push them around and the magnets either attract each other or push each other away, and you must give this little puck in the green goal. And it's in 3 dimensions. It's pretty cool, and the physics behind it is also quite nice. For me, it's a very, very lovely example of how to teach and how to make very technical stuff very interesting. Good. This was the end of my slides. Now let's try to do some live coding. And we will start now not with the web Vpython thing, but with the real Python. So Thomas has now a real terminal, and he opens a Python interpreter by just typing Python. I must add that Thomas makes this now the 2nd time in his life. The first time was in the morning when we made try one. Okay, now he imports Vpython, and ideally import Vpython as VP. Python as VP. It's just that he does not have to type so much. Okay, and now how to start the whole thing, you say vp.box. parenthesis, parenthesis. Very cool. Okay. And now we have a box, and Thomas will adapt so that we see the terminal always in the foreground. If you ever worked with turtle graphic and Python prompt, I think you know this procedure. So you type and you instantly see the result. And now what you can do, Thomas, if you can show how to rotate the cube with the right mouse key. Also if you hold the right mouse key down and rotate, you see it's a real 3D graphic. This 3D thing, we just set as a box, but as you can see, there's also a lamp. The lamp was automatically set because otherwise we would see nothing. Also it's a working 3D environment. It's also possible to pan the whole camera by holding a left shift key and left mouse button at the same time, which is a bit difficult on the laptop. And if you have a mouse wheel, you can also zoom in or zoom out, which is now super difficult because Thomas must use the touchpad and two keys at the same time. Okay, you see you can also zoom, pan, and rotate your 3D objects. You see also here that a 3D object was generated. Okay, let's make it again, but this time let's put the object in a variable so that we have later access to it. Would also work here, but not so elegant. Maybe make Ctrl-C to kill it and then start again. Yeah, this is... Don't look at this, you should see this later. Okay. No, don't look. Okay. Okay, so... Python, okay, import Vpython as Vpy. Okay, now we put it in a variable, let's say b equals vp.box. Yeah, very good. And now we can say b.color equals vp.color.yellow. vp.color.yellow. You see, you have still access to your objects and can still manipulate them after creating. Yeah? You just have to put them in some variables. Okay, now I'll show you what I usually do in workshops, and I like this very much. I sometimes try to use this when I teach Python in classes, and I know they will maybe not become software engineers because the class is in a total other direction, and I just want to show off what you can do with Python. So instead of doing turtle graphics, I sometimes try to start directly with 3D graphics to impress the students a bit more. And I will just try to explain the concept of for loops that, of course, you all understand. I think we don't need to do it live. Let's just open the Horst1.py program in our environment. I wrote them 5 minutes before. Okay, you see, basically, okay, this is a bit more difficult for loop because it has 3 loop variables, but in principle I have here 3 vectors, 1, 0, 0, 1, 0, 0, 1, 0, and 0, 0, 1. And the nice thing in Vpython is you can use a vector with 3 dimensions also as a color attribute to say the red, the green, and the blue tone of an object. If you run this, you should see 3 arrows. Yeah. Maybe we must switch to some browser now. Maybe close the yellow thing first. Okay, and close all the other ones. Yeah. Okay, and now. Yeah, he opened. Yeah, you see. And now we have 3 arrows, which is very handy if you want to understand the X, Y, and Z orientation of your objects. And Thomas can, of course, manipulate them. You notice there's no main loop in all these programs. So he has this also automatically. You just create the object and the Vpython waits for user input from the mouse and still displays all the objects correctly. Okay. And what I like doing is, if you just show Horst.2, but first please close the previous program. Okay, super. Yeah. I'm very happy that I don't have to click around now. Here's the same program with the same loop that you see before, but I added in line 9 another loop with the range commando to create a number of boxes. If you start this, you see instantly a row of boxes. and you can move this around with the camera and rotate, which is usually for young students really impressive, and then they start to say, and can I make a 1 million cubes? And I say, yes, go on, try. And then they found out that the camera zooms out automatically and they don't see them. But it's nice, it's invite for experimentation. And let's go to the next programs. And then I usually take this to try to explain what is a nested loop, a loop in a loop. So here I make another round for Y and then another round for Z. Can you jump to Horst 4.py? Yeah, and if we have this, we have done 3 columns of boxes, but this is 3 loops that are not nested. This is just 3 loops behind each other. You must rotate a bit. Rotate, yeah, you see it's 3 times a row of around 50 cubes. And now the next program tries to nest them, and then we have a cube of cubes. And so it must be Horst 5.py. Yeah, you see, I now made one loop, so the loops are now nested, and I have in the end a box with 3 different parameters. And if you run this, we have now this cube made out of cubes, which has a nice interference pattern, like in turtle graphic. Okay. Huh?
Welcome to the
yeah. Yeah. It's a bit more impressive if you have a mouse with a mouse wheel and zoom to it yourself. But you see, the code was really not much to type for relative impressive output. Okay, and the nice thing is, I said before that you don't have a main loop in Vpython, it works, but you can use a main loop, and when you use a main loop, you can then better control what happens over time and can make like animation or color cycling effects. And these are made in the, I think in the program 6, let's see, 6 or 7, what is the, oh yeah, here, let's don't start it, let's just show it. I appended now, so the box objects in line 19 are now appended to a list so that I can later iterate over the whole list. Strictly speaking, it's not necessary. Vpython has a reference to every object, but so it's more handy if they are in my list. I know only the objects that I want to manipulate are in this list. I don't have to iterate over all objects in the screen and then think about if this was a desired object or not. Okay, I put basically everything inside a big list. I call this box list. And now in line 7, I can show the loop. Yeah, let's walk through this program. Yeah, I made back to line 10, please. Yeah, I said I have now 55 as an end stop value for the range so that the students can later change this 55 to 500 and see if their graphic card can still handle it. And what we have here, we have a lot of boxes who are all in a big list. And now comes the main loop, starting in line 22, if you can scroll down, please. You see there's one while true loop, and the only thing you need is into line 24, this Vpyrate commando. It should tell that the whole simulation does not run faster than 60 frames per second. So it has an internal sleep command, and that's all, and then you can make inside this loop whatever you want, so react to user inputs. And here I just say every cube shall rotate with a different speed. So he increases the speed. And if you start this simulation, this is now what you have not looked at before, hopefully. And can you zoom slowly in? You see the bit glittering? This is because the cubes rotate and then the reflection of the light is different, but you should see now that some cubes rotate faster and some slower. I think on the first row you can see it relatively good. Okay, yeah. So this is all possible with relative few lines of Vpython, which I like very much, especially if I want to teach Python. Okay. I now show you together with Thomas about the close script, also this Vpython environment that runs inside the web. Let's close this one. and go to the closed script side, you see Thomas on the top right corner has already logged himself in with using a Gmail address. He's now Mitzka148. And when he now clicks on the lower right corner on the example programs, he sees here example programs. As you can see, sorry, can you go back to the top? The same example programs also exist as in JavaScript, and actually in JavaScript they're even a bit faster because all this from Python to JavaScript is reduced. So the whole point of it is that you can do things that you can do in JavaScript and you can do them in nearly Python or in Python, but it's not a speed improvement to use Python. Okay, and you see there are several programs. Let's see the double pendulum. This program is very nice because it makes use of some JavaScript libraries. And the nice thing is you have graphing libraries in it. You must just scroll a little bit down. Yeah, very good. You see there's a run and a graph button, and the Vpython also provides you with widgets like buttons and sliders and input fields, so you can make your own dashboards with simulations. It's not fancy, it's not drag and drop, but it's possible, and I think it's everything that you need to make a little simulations like this. And if Thomas, yeah, can you rotate the whole thing to show it's real 3D? Yeah, so it's a pendulum that swings. The whole physics is of course made in the Python code. And if you click on graph, you should, on this graph button, you see here an updated graph, which is of course a JavaScript plotting library. But I think it's neat, and especially for this purpose that you want actually to teach something about physics or use something. It's very nice. Maybe you can show the code when you say view this program on the top left, the blue link. We now inside this closed script editor, and I think he has not much more than 50 lines of code. Let's see. Okay, a bit more. Okay, a bit much more. Okay. It is a small. Okay, it was not written. Okay, but it's still Python code. Okay, let's go back. What I like most is to have something that is a bit gamey, because I work much with young students, and for this I can recommend two things from the Vpython batteries included library. And this is, if you scroll a bit down, you see here, it's in the right, click here for an index of M and I programs in the green button, right, yeah. And if you click here and run, something strange happens. He has somehow unpacked programs that are shipped together with this matter and interaction book, and from them are some very nice. For example, the space station. We want to show you. I must say now that Thomas placed the space station now to the second time in his life. You have a space station with two cameras, and one where the camera rotates with the space station and one not, and this little astronaut is here now controlled with the green dot, and he flies in the space station. And you see here how the flight path changes depending if the camera rotates with the space station or if it's stationary. Can you once again make a click? Yeah, and it's a nice gimmick that you can do here. And the other thing that actually every student that I showed it until now loved it is, I think it's 11 or 6, this electronic field hockey program. Ferris wheel. 13, sorry, no. Electric, yeah, okay. Yeah, electric field hockey, 13, yeah. And this is a program that needs a bit longer to start on the laptop of Thomas, but we managed to get it running. I showed it before in the presentation. Thomas, you just tried to get it running, and yeah, it has several levels. The sad thing about this is that the source code is not included. So it's a bit harder to figure out what is really happening. The nice thing is you have these red magnets who push the blue part away, and the blue magnets who attract it. And you should try to create, so to position them in the right way to put a little hook in the goal. Top view is working? Ah, yeah. Nice. No, too slow to show. Ah, yeah. Okay, yeah. Just click on one. You see, he was now attracted to the little book, and he go to this right magnet, and if he would change them, but sadly we're now slower than before. Then try. Now the blue pushes the other blue away, so he must position them to the left, and then he would maybe score a goal. Yeah, okay. Yeah, and nearly. Yeah, super goal. Yeah. And then super Thomas. And there are several levels where it becomes more difficult with obstacles and all sort of things. Okay. Yeah. So far to close script. I think we can turn off the screen now. Now I will just talk about my experience in using it in production and as teaching tool. I try to show you a bit what I make usually in introduction workshops. I used Vpython a lot during the lockdown in COVID, where I had distant learning classes, and how should I say, the results were mixed. Some students loved it, some just followed along because I was the teacher, and some turned the screen off sooner or later, but I cannot exactly say it was because of my teaching or because they don't like 3D graphics or because it was general the COVID situation where the children were annoyed and out of school and not very responsive. I think that Vpython is a very good tool, especially for young students, to get them into programming, to explain them concepts of 3D and of mathematics, which they are usually a bit familiar with from playing 3D shooters or games. For example, I myself really only understood what a cross product of vectors is when I worked with Vpython. I learned it before, and I know what it is, that it exists, I know, but it was always like a Chinese vocabulary for me. Okay, I must learn this, and I know where to read, how to calculate it, and only by playing around with Vpython I can, okay, it's how to position the third vector if I have already two. So for me, this was very nice way to make yourself more familiar with three-dimensional graphic concepts. What can you do with Vpython? Well, I tried, because my love is Pygame, so the game library for Python, who makes 2D graphics, and I was thinking, okay, and now I can do all the things I wanted to do with Pygame in 2D, I can now make in three-dimensional graphics, and I tried very hard to make a flight simulator in Vpython. We can look at the results. It's the doppeldecker.py, I think. We got it running before, so I hope we will manage it now. Yeah, Python doppeldecker.py. Doppeldecker means B-plan in German. And you see here, I made, of course, tanks. And now if you push the letter 5, I think, to start the engine. Yeah. Yeah. We don't get it running now. Sorry, guys.
Has worked before.
Has worked before, yeah. Not two guys. Score how to engine. Single doesn't. Yeah. Yeah. Okay, I'm taking off. I think we're stuck in the ground somehow. Yeah. We're not flying. Okay. Reload, yeah. It's reload.
It's a driving simulator.
Yeah, I did not mention. Maybe we must close the other things. Yeah. Close everything else. Sorry, guys. Okay, it does not work. Yeah, I'm flying. Okay, okay, and I managed to have little tanks. This was before the Ukraine war, and then I can also fire it and fire. Can you scroll me? You see the tanks are moving around and follow the. Yeah, you can see that I'm shooting and have the impact, as you see here. Okay, and the goal was then to fly through these loops and so on. So, in the end, I got it running, and I had my fun with it, and then I coupled it with Pygame, because I did not know how in JavaScript to access the joysticks, and I was too lazy to look it up. And in the end, I had a game, a flight simulator that I programmed myself, where I can fly with my joystick and control my B-plan, and then I made some point system that I fly to the loops. Yeah, and that was it, but I must say, from a efficiency point of view, it's far more clever either to make the whole thing in JavaScript if you want your 3D output in a browser, or if you like a Pythonic environment, to learn Godot, which is in GDScript, which is very Python-like. It's, how should I say, you can do something with it, but it's not the most efficient way for 3D programming. But it was not my point. My point was to make something funny in Python, and I managed, and I was happy with it, but I understood if I want to charge money to teach students game programming, it's maybe not the ideal direction, at least not after a certain point. For an introduction, it's great. So this leads to the questions for what is Vpython good for. I also used it for commercial projects, for data visualization, and it's also perfect to make a quick prototype to show a client, look, we can do this and this with your data, especially because Python has a rich ecosystem like polars and pandas to process big data, and then you can create something with it that is a bit outside the standard matplotlib graphs that they know. So it's nice to combine your creative ambitions with some hardcore Python skills, but also in the end, I have currently a project with really gigabytes of data, and they should all be visualized. And then we reached a point in this project where I had to say my customer, maybe Vpython is not the ideal solution for that, what we're doing, because after some point, too much is going on, the frame rate is dropping, and the fact that we use Python to actually do something in JavaScript is great from a programmer point of view, because I don't have to touch JavaScript, I stay in my Python environment, but I pay for it with even a bit more speed loss, and JavaScript is also not the fastest to make smooth 3D programs. And so in the end, my conclusion is, if you want hardcore game programming, maybe it's better to learn Godot 3D programming, than you have a Python-like system, but it's compiled and it's really designed from the ground up for games. If you have something that should display data in a web browser, and it's a bit more complex than what you can do with Vpython, maybe it's better to use one of these thousands of JavaScript libraries who are made for this purpose, like 3.js or something. So in my experience, what I experienced so far, Vpython is kind of a jack of all trades and master of none. It's designed for this very special use case of a physics teacher who wanted to do something for his students, that they don't have to have a degree in computer science, that they can quickly visualize something and play with it, have a very simple main loop where they can concentrate on their formulas. And for that, I think it's great. And I also think Vpython gets far too less recognition than it deserves. So I think it's a fantastic tool, especially for teaching. If your requirements of output are not super high, I think it's really a very nice tool that gives you much flexibility. Of course, Other tools like being in pure JavaScript will give you far more flexibility. Here you have seen the graphs and the widgets, you can do them, but you're restricted in how you arrange them on the screen, and you are restricted in which you use. And then when you think, this is JavaScript, actually I could combine it with another JavaScript library that I want, then you soon reach the point where the whole thing maybe is better done without Vpython, as I said before. But it depends really on the use case. So my conclusion is, take a look at Vpython if you have a slightest interest in 3D graphics and Python. Play around with it, maybe you find a use case for it. A program don't has to be perfect in everything to be fascinating. Thank you.